In this unit, we're going to be looking at a very powerful technique called root locus. And so what our root locus technique is a graphical representation of our closed loop poles of the system as some system parameter is varied. So for example, the gain of the system. And so this is a relatively complex topic, and so what we're going to do is sort of step through and incrementally advance what we know and how we can approach the problem. Ultimately leading up to, in class, we're going to look at how we can use MATLAB to plot and analyze our root locus. So first, let's just talk a little bit more about what our root locus can do for us. So we're going to see it can provide sort of a quick qualitative look at what our system is doing, or it can provide a more in-depth quantitative analysis as well. So it's going to provide qualitative, so we could do sort of just a quick sketch, and or a more quantitative detailed plot. And so we're going to start, of course, by sort of doing a basic math review. We're going to look at sort of some simple plots, and then we're going to come back and say, once we have this qualitative quick sketch, how can we improve on that and make it a little more detailed? And so it's going to have some info for our stability. It's going to have some info for our transient response. So it's going to have a lot of useful things that we can sort of pull from. So info on stability and our transient response. And so ultimately, this shouldn't be too surprising because our root locus is going to be a plot in our complex plane. And so in our complex plane, just based on where our poles are, from previous units, we know certain things about the time response and the stability of the system. So a key point about our root locus is that it's going to work for systems with higher order than 2. So let me change that, not with, getting ahead of myself there. So this works for systems with order higher than 2. And so of course that's a pretty big deal because up to this point we've been saying, well, is this a second order system? No, well, maybe we can approximate it as one. So now we're saying with this root locus technique, we can easily deal with systems of much higher order, and we'll see how to handle that a little later on. And another useful thing about our root locus is we can find most of the information just from analyzing our open loop transfer function. So we don't necessarily have to go through all the details of finding our closed loop transfer function. And again, of course, that's something we're going to touch on a little more later. So most information from analyzing our open loop transfer function. And the benefit of that is, of course, it's just one less step in terms of reducing to find our closed loop transfer function. But in some cases, that might not be too much of an issue, particularly if we're using MATLAB. You know, it's not too much of a big step to reduce that system a little more. So this is sort of a good starting point in terms of what our root locus is in general. And as I mentioned at the start of the video, we're sort of going to incrementally add to our knowledge about this until ultimately we'll be able to do detailed sketches and use MATLAB in order to analyze systems using the root locus plot.